So what you see here is a robot that can avoid obstacles automatically without the need for us to control it. So how actually this robot can move around without any controls? So basically, if you see here, it obviously, because it has these two eyes here, so these two eyes here makes this robot can easily navigate through the movement and see the obstacles. So how does this eyes works? So this eyes is actually made from the ultrasonic sensors. So how does the ultrasonic sensors work, and how we can program it so that it can avoid obstacles? So all of this will be discussed in this video, so please watch this video out. Right, so first thing first, what is actually an ultrasound? So ultrasound is just a sound, but we can't hear it because it is actually a high-pitched sound waves with frequency higher than the audible sounds that we can hear as humans. So we humans can only hear from the 20 Hz up to 20 kHz frequencies only. Above that is what we call the ultrasound. Since this is higher than the audible sound, and therefore we can't hear the sound. So basically this is what we call an ultrasound. And here is this ultrasonic sensor here that you can see here, or the HC-SR04 here, is basically a distance sensor which consists of these two ultrasonic transducers. One which acts as a transmitter which convert electrical signal into 40 kHz ultrasonic sound pulse, and receiver, and one more here is the receiver, which listens back, because it is a sound, so it needs to listen back the transmitted pulse. If it receives them, it produces an output pulse whose width can be used to determine the distance of the pulse traveled. So basically as simple as that. It is small, easy to use in any robotics project, and offers excellent non-contact range detection between 2 cm, as small as 2 cm up to 400 cm, with an accuracy of around 3 mm. So again, since it is also operates on just 5 volts only, so we can use this ultrasonic sensor, we can just directly connect this ultrasonic sensor directly to an Arduino or any other 5 volts logic microcontroller. So this here, if you can see these circuits here in the Tinkercad here, is how we can connect the ultrasonic sensor HC-SR04 to the Arduino. So if you use the Tinkercad as usual, you can just search for ultrasonic sensor here. So basically it will come up with 2 different ultrasonic sensors. So for the HC-SR04, you choose the second one, the blue one with the 4 terminals here. So this is the HC-SR04, and to connect it, basically ground is connect to the ground, the VCC is connect to the power supply, 5 volts again, and we have the echo and trigger which were connected to the digital outputs of the Arduino. So this is, if you want to construct this circuit in the hardware, as usual, you can just pause this video anytime you want, and then you can start to assemble these circuits, and you can click the play again if you are ready to proceed again. So this is the HC-SR04 connection to the Arduino, as simple as that. So basically, how does this HC-SR04 ultrasonic sensor works? So if we look at this here, so basically it all starts when a pulse of at least 10 microseconds here, if you see, applied to the trigger. You know, we have the trigger pulse and also the echo pulse, as I shown previously, trigger and echo pulse. So this trigger and echo pulse, the trigger will trigger about 10 microseconds of pulse. And then in response to that, the sensor transmits a sonic burst of 8 pulse at 40 kHz here. So this is the 40 kHz pulse. With the 8 pulse, these 8 pulse patterns makes the ultrasonic signature from the device unique to each other. So if you have different ultrasonic wave, so basically it knows which one is actually triggered by the trigger of this ultrasonic sensor, not the other ultrasound patterns. So this is how it differentiates between the different transmitted patterns or the different ambient ultrasonic noise. And this 8 ultrasonic pulse here travel through the air away from the transmitter, and this echo pins will goes high to start forming the beginning of the echo back signal. So just like that, so this transmit 10 microseconds with this 8 pulse, and then it will trigger high, the echo will trigger high to start forming the beginning of the echo back signal. In case, let's say like this one, the pulse are not reflected back, this pulse here are not reflected back, then the echo signal will time out after 38 milliseconds here and return low. So basically it will return high, and then after 38 milliseconds it will drop to low again. Which this 38 millisecond pulse is considered indicates that no obstruction or no obstacles in front of the this ultrasonic sensors here. So in other words, if no obstacles, then it will goes back to low again. So this is how for the first part when there is no obstacle. But let's say there is obstacle. So if there is obstacle like this one here, so basically it is a sound. So sound can reflect back. So basically after it transmit 10 microseconds with this 8 pulse here, and this pulse here will be listened back by the echo pulse. When it receive this signals back, or the reflected signals back, what it does, it will directly goes to low as soon as the signal is received, and this produce a pulse whose width is varies between 150 microseconds to 25 milliseconds, depending upon the time it took for the signal to be received. So let's say for this example here, because the obstacle is not too far, so basically it only trigger highs for a certain amount period of times, and then it will directly go low when it receive the sound reflected back to the ultrasonic. So that's why the length of this data here is quite small, because the reflections or the distance is not too far away. So if the distance is too far away, it will wait until 35 milliseconds that I mentioned in the previous parts. In other words, it just keep high until it receive the reflected sound again. And when it goes down, so basically this periods here, this 500 microseconds, or the T of it remains high here, will be considered as the distance. So basically how long it goes high is the distance. That's it. In other words, how long it goes high is the distance. The longer the period it takes to remain high for the echo, the longer the distance are. The shorter the echo remains high, then the shorter or the distance is shorter, and that's it. And this width of the pulse of the received pulse is then can be used to calculate the distance or to the reflected object, which we can calculate by using this formula here. The distance equals to a speed times time. So speed times time. So that's it. So the time is basically how long it goes high, so which is this one here, the 500 microseconds here. So the time will be 500 microsecond. 500 microsecond, because this is the time it goes high. So this is why we use 500 microsecond. So let's say if the time that it remains high is longer, so then you change it here, the values of the time it remains high in these parts here. Yeah, so that's it. And for the speed, so again it's just a speed of sound. So speed of sound is just basically if since this is in microseconds, so we need to use the speed of sound in microseconds. So you can find it in Google, so just Google it now if you want to know what is the speed of sound in meter per second. But in here I will use centimeter per microsecond, again per microsecond, because this is in microsecond. So we use a microsecond, so cm per microsecond. Why cm per microsecond? So again, when we cancel out microsecond and microsecond, so the distance that we will get will be in cm. So this is depending on the distance that you want to convert. If you want to convert it into the meter, so it will be meter. But if you want to convert in cm, then that's why here I use cm. And because this is microsecond, so that we can cancel it out, and therefore it only left with just cm here. Yeah, so that's it, as simple as that. And if you already find the answer of the speed of sound in Google, so again this is just a speed of sound from Google. So basically you will find the speed of sound in centimeter over microsecond, or centimeter per microsecond, is 0.034 centimeter per microsecond. But this is actually the time it transmit and then reflect back. So basically it transmit and then reflect back. So this is the time. So this is the total time from the transmission until it receive back. But if we want to know just the distance here, so basically the total time, the total time must divide by 2, because we just want this one-way signals only, not transmit and receive, and we just want one way only because that is the distance. Because of that, we need to divide this all by 2. So if we divide all by 2, then we will get the distance from the ultrasonic sensor to the obstacle, and that's it. And if we calculate this, so you will get the distance in cm should be 8.5 centimeter. So this is one example. This formula here is what we're going to use into our Arduino coding later on. So again, remember this formula here, which means that the distance that we will convert into our Arduino is basically just distance in centimeter. It convert into the Arduino, we will get 0.034 times with the t over 2. So this is what we were going to use in our Arduino to convert the value of the t into the distance. So that's it. Basically this is the coding, the main coding for our ultrasonic sensor, and that's it. That's how the basic concept of the ultrasonic, and how we can get the formula of the ultrasonic, how we can know the distance based on the sound reflected back by the ultrasonic. And that's it. Just a basic concept only for this video. And as usual, before we end our video here, I show you again the circuit, so that you can construct the circuit before you proceed to the next video. So this is how the circuit will looks like. One will goes to the ground, one the VCC will goes to the power supply, the trigger will goes to and trigger and echo will goes to the digital ports, and that's it. This is if you have hardware, and as usual, if you don't have hardware, don't worry, you can use the Proteus here. So the Proteus here, but the problem with the Proteus, not all Proteus have this ultrasonic components here. So let's say if you don't have the ultrasonic components in the Proteus, so you need to download it first. So you need to download this ultrasonic components first before you can find it in the Proteus by going to the Google. Just go into the Google, search for the ultrasonic sensor HC-SR04 Proteus Library. So if you search this, then it will goes to this the engineering project website. So you can download from this website here. Goes until and download the ultrasonic sensor, and you will get the zip file which containing these 3 files here. So you download into whichever directory you want to save it. So you have this raw file here, so just open it, 7z open archive. You can open it in any software you want to use it, and then transfer it just like we transfer the Arduino library that I showed in the previous video. So if you don't watch that video that I show how to transfer the Arduino library, so please watch that video. I will provide the link up top or down below. So I just show it roughly here. So just open the computer and then goes to the program data. Again, if the program data is hidden, so goes to view and then unclick the hidden, just click the hidden items. So if you unclick it, it will hide the program data. But if you re-click it again, so it will appear the program data, and then find Lab Center Electronics, Proteus 8 Professional Library, and then copy and paste all these 3 files here into the library file. That's it. When you already done that, the ultrasonic sensor library here will appear in this ultrasonic sensor will appear in this Proteus. So again, use this one here, ultrasonic TEP, or maybe you can just search for HC-SR04 if you have it, HC-SR04. So this one here, so you can also use this, but I don't usually using this because it does not give it somehow always goes low. The values of distance always going to zero, and therefore the values or the outputs will always trigger the alarms, or it will behave not in what I want it to behave. And that's why I don't use this. I use the TEP. So basically the ultrasonic, again you can find the ultrasonic sensor, the TEP, and then OK, and then you can add here. So again, ground goes to ground, 5 plus 5 volt goes to power supply, and then trigger, and also the echo to the pin 2. And don't forget to use this virtual terminal here. Why we need to use this virtual terminal? Because we want to display the distance in the serial monitor. So because of that, don't forget to put this virtual terminal here, and don't forget to include at the test pin here this potentiometer. Why we need this potentiometer is because we can't test the distance in this computer. So how we can test the distance is basically just by using the potentiometer. So the potential, when we vary the value of potentiometer, it will simulate the distance of the obstacles. So if we reduce the value, so it means the obstacle is getting closer. If we increase the value, it means the obstacle is getting further from the ultrasonic sensor. And that's it. And that's why we need this potentiometer here, and that's how you construct it. That's how the circuit will be. And again, if you need time, so you can pause this video to construct this circuit here in the Proteus. If you need to use the Proteus for your simulation, if you don't have hardware, again, if you have hardware as usual, just go to the, just assemble it on the breadboard and directly with your Arduino. And that's it from me for this video. For this time around, just a theoretical background for these parts here, and hope you understand the concept or the working concept of the ultrasonic sensor and how we can measure the distance based on the sound. And I think that's it for today. Hope you understand, hope this video here helps, and hope you like this video. As usual, if you like this video, please give a thumbs up down below, and don't forget to subscribe if you want to know more about Arduino or electronics in general. And that's it from me. Thank you very much for your attention. If you have any comments, if you have any problems, any questions, feel free to ask me. You can comment down below or just message me. And that's it. Thank you very much for your attention. Stay safe, stay curious, and stay joyful. I'm Ikhwan. May God bless you. Assalamualaikum.